All right, so in this hopefully last video, we're talking about what are called piecewise functions. And so what this is that you have a function that is made up of multiple functions or multiple equations, each of which is defined over a certain part of the domain. So for instance, here we have f of x, which has three different linear definitions or different linear functions depending on what part of the domain we're in. All right, and so we just have to think about when we're evaluating this, we've got to say, okay, which part should I use based on where my input lies, right? So if we look at and we want to find f of -4, we're going to say, well, does -4, we have a part for less than -2, we have a part for 2 to 4, and we have a part for greater than 4. So if my input is -4, that's over here somewhere. So we're using that first piece to figure out what our function is. So -5 times -4 minus 8. So we're looking at 20 minus 8, which will be 12. So yeah, don't make these any harder than they are, right? So this next one, we're being asked to evaluate f of -2. So we're going to look here, we're going to say, is -2 less than -2? So no, it's not this one. Is -2 greater than or equal to -2? Yes. So we're going to go with the middle function. So we're going to have 1/2 times -2 plus 5. So -1 plus 5, which is, of course, 4. And so on and so forth. So like the next one, so this we could call it, we could say, hey, this is, piece 1, piece 2, can't spell, piece 3. So this one, our -4 falls in piece 1, right? Our -2 falls in piece 2. Our 4 also falls in piece 2 because 4 is less than or equal to -4. So we're going to have to say, okay, 1/2 times 4 plus 5, which is, of course, 2 plus 5, which is 7. And then we're going to say, okay, f of 6. So 6 is over here somewhere. That's in piece 3. So we're going to use 10 minus 2 times 6, which will be 10 minus 12, which is -2. Now, of course, it would be nice to be able to visualize this in GeoGebra. Now, there's two ways. And one is to kind of build this piece by piece and have each piece be its own function. So what I can do is I can type in f of x equals -5x minus 8. And then I'm going to put a comma, and I'm going to say, hey, x is less than -2. And as soon as we do that, oops, I made a typo. Oh, no, it is -2. As soon as we do that, we can see that GeoGebra has graphed this line, but that it stops. It stops right at -2 for the input. And then we can do our next part, g of x, and that was 1/2 x plus 5, and we'll put a comma, and we can say -2 less than or equal to x less than or equal to 4. And so you can see as soon as I did that, it basically chopped off the line, so only that part of the domain had that part of the graph. And then we have our last part, let's say h of x is equal to 10 minus 2x, comma, x greater than 4. And so you can see, there we go. And the only thing that this doesn't kind of automatically do for you is those endpoints. It won't put the open circle or the closed circle on there for you. Now the other option, you can tell what I learned first. The other option is to put this in, if you know any sort of computer programming, then you've, I'm sure, done if-then statements. And you can do, cancel. You can do basically a giant if-then statement. You can say if x is less than -2, then we're going to do -5x minus 8. Else if -2 is less than or equal to x is less than or equal to 4, then do 1/2 x plus 5 otherwise, else if. And I'm not sure you need the x greater than 4. Let's see if we do. 10 minus 2x. We don't. But you could basically just keep going until you have all your parts. And the nice thing here is that it puts it in that same notation. And you can see, because I left off the x greater than 4, that it just said otherwise. So if we go add that in, it'll have all those pieces in my function. You can see if I do this, it just lays right on top of the one that's all together. So your choice as far as visualizing, and the only thing you really have to think closely about is those endpoints and which ones are closed dot and which ones are open. Okay. So well, that was a long explanation for that one. So let's take a break and see if we can get the other two in on one video.